So we talked about finding displacement first. And Evelyn was the one who gave us the clue as, how do we find our displacement? So what did Evelyn talk about when we said, well, how do we find where we started to where we finished? We can look at our picture again. Maybe, come on. What did we do with this picture to find what was his distance he traveled just from starting point to finishing point? It was the area under the curve. And we didn't do anything to the area, we just took normal area. We didn't have to change it in any way. So displacement is area under the curve. Or mathematically, it's just taking the integral from a to b of our velocity. And definition-wise, displacement is just our distance from where we started to where we finish. We talked about position last, so I'm going to hold off on that. We talked about total distance traveled next. How do we find total distance he traveled? So how many steps he actually took and not just where he started to where he finished. The absolute value of the area under the curve. So the total distance is still the integral from a to b, but it's the absolute value of velocity. We also talked about direction he was walking, whether he was walking backwards or forwards, when he switches direction. And I'm going to add those in. I just want to talk about position last. So, how do we know when he switches direction?
Positive to negative, or above the curve to, or above the x-axis to below the x-axis.
So we went from above the x-axis to below the x-axis, or below to above. So what kind of mathematical point do we call that when we switch from above to below the x-axis? The zeros. He switches direction when velocity is 0. We have those zeros. And then how do we know if he's walking backwards or forwards? Negative and positive. So if the velocity is under the x-axis, negative, above the x-axis, positive. So backwards, the velocity is less than 0, and forwards, the velocity is greater than 0. So out of all of these, I think position is probably the hardest to work with, because we have to be able to think about it in a couple of different ways. The first way we wrote up on the board. Does everyone have this before I scroll back up the pause for a second? So position, we said, well, if we take the starting point and we add the displacement, we get the final value. But again, we want these in terms of algebra. We want some algebraic terms for this. And we've already decided what the algebraic version of displacement is. What's the algebraic version of displacement? The integral right above. We said displacement is the integral from a to b of v of t dt. Well, how would I represent starting position algebraically? What do we usually use to represent position? t or s of t. But specifically, where did our time start? We don't want to just say t, because t could mean any time. We want starting time.
S of 0.
Our time started in 0 on this particular one, but what if I just wanted to look at what happened from 5 to 10?
S of A.
S of A is where our integral starts. S of A. Or X of A. It could use either. So then what would our final position be?
S of B.
S of B. So we can think of it this way, but we're used to thinking of it another way. What if I move S of A to the other side? How would I do that? Subtract it.
Oh.
And it sounds like most of you have recognized already what this is.
That's crazy.
What is this? A fundamental theorem of calculus. If we take a function and we integrate it and evaluate it at its final position, or its final time, minus what our position is at our initial time, we get our displacement. We need to be able to think of this in both ways. Some ways it's easier just to say, okay, starting position plus displacement, but sometimes they're going to want you to actually find starting position given final position. So we need to be able to move stuff around and work with it. So I think that's where we're going to stop for today. Brain keeps freezing. We'll start doing some examples of this tomorrow, and we'll also have some AP examples of what they're going to ask you on the AP test for this. Like I said, it actually comes up way more often than I always expect. Like, it just comes up in quite a few problems built into some of the other things they're asking you.